Assalamualaikum warahmatullahi wabarakatuh. Here I will explain the first two materials about aeration, and the second about water treatment. Aeration is the process of touching, contacting water with oxygen. The function of aeration itself is to allow oxygen to enter the water so that the water contains dissolved oxygen. There are two kinds of aeration, namely natural aeration and artificial aeration. An example of natural aeration is rippling water in a river, usually high oxygen and phosphorus fields. This is that the waves on the beach are the biggest source of aeration. Aquarium aeration. So, why do you need an aquarium pump? Namely, by spraying air into the aquarium. So if the pump is turned off, what happens? The aquarium pond is cloudy and usually susceptible to dead fish because the amount of oxygen that is inside will decrease when no air is pumped in. Its function is when oxygen is pumped in. Water will increase amount of solvent oxygen we see in the water that we see clear, but it turns out that it is not necessarily clear. The ions that are dissolved in it, even though it is filtered. For example, we want to know the level of Fe. It will not appear. It turns out that aeration will have oxidized dissolved ions cannot be filtered, but if they have been oxidized. Superlarge aeration and the benefits are very large. Namely, in the waves on the other side of the beach there is sand. The sand there is fine, smooth, not sharp. Then, where does it come from? It turns out that it comes from the sea, which is rich in ions. These include oxide ions, which are abundant in the presence of oxygen, dissolved oxygen from aeration. When there are waves, it is aeration. When dissolved oxygen is high, it's not only the biota that benefits. When the dissolved oxygen is high, it will make the next process, namely the minerals in the sea to form their oxides. We know that the solid oxide form, the first solid formed, could not be as large as the sun must be small. The small one then gathers below crystals. It will make the previously soluble to be insoluble because it changes its shapes, its compound, and forms a solid. Well, it will appear sand. To separate the sand in the water is done by contacting with oxygen. This process is called matching. In industry, blowers are usually used to pump air into the water. In the sea, when a rock is hit by a wave, it won't shrivel up. Why? Because it will place a layer of rock so that it makes the coral stronger, like the crust on the walls is caused by water. For example, here we take a sample of water from urban areas taken by comparison, namely plus alum and one without alum. As a result, water given alum can agglomerate dirt so that it becomes clearer, and when filtered, it will become clear. Processing method using alum or alum chemicals. The first is taken a dirty sample from urban areas. The two waters that were given the alum turned not clear and the phases fell to the bottom. The third, after the filtering process, the water becomes very clear. The way alum works in water purification is to agglomerate particles or neutralize particles so that they can settle. Dirt is a colloid in dirty water that repels each other. With the presence of alum capable of making it attractive and which can be layered or double layered, meaning that the first layer is attracted and the second layer is attracted so that over time it becomes thick and rough and then it will settle. The first method of processing drinking water is screening where her is given alum or aluminum sulfate or alum to filter out impurities. The second is coagulation, flocculation by providing coagulation and assisted by stirring so that the interaction easily settle. The third is clarification or sedimentation, which is where the dirt will settle, so that the process of settling dirt goes slowly. Fourth, filtration is carried out using slow sand media. The water will pass through the sand and move very slowly. The function of sand is as a filter or binder. This happens because of the absorption event. Coagulation is the addition of chemicals to destabilize the electrostatic forces of non-stable solids. Coagulant chemicals typically have a positive charge, which binds to the negatively charged particles in water, neutralizing them and allowing them to come together to form small clumps of particles called microfloc. In most cases, the chemical reaction occurs in a fraction of a second, so it's important that coagulant is dispersed quickly and evenly to encourage as many particle collisions as possible because this process relies on chemical reaction. Several considerations must be made. Water temperature, for example, colder water usually slow coagulation and flocculation reaction, which may require more time to achieve optimal floc formation. Extreme value of pH, high or low, will also interfere with the process. Coagulant effectiveness is highly dependent on pH. For some coagulant, alkalinity is a factor. Operators may need to raise validity for coagulation to be effective when using iron of aluminum coagulants that can consume alkalinity and depress pH when they are added to low alkalinity water. Turbidity is also important. The lower the turbidity, the more difficult it is to form proper flow. The most common coagulant chemical used is aluminum sulfate, commonly called aluminum. When added to water, aluminum forms jelly-like particles of aluminum hydroxide. The trivalent aluminum ions neutralize and attack to negatively charged particles in water, forming microfloc. Aluminum for works best in a pH range of 5 to 7.5. Polyaluminum chloride and iron salts such as ferric chloride and ferric sulfate are also used. They operate over a wider pH range. Coagulant and flocculate edge are added to improve binding, build stronger, more settleable floc, and affect flocculation by increasing floc air strength and or floc density. In addition, they help overcome the effect of low temperatures, reduce the amount of sludge produced. Commonly used coagulant aids include cationic polymers. Polymers are defined as a synthetic composite compound with high molecular weight and composite or repeating chemical units or monomers. Polymers may be polyelectrolytes, such as the water-soluble, flocculants, water-insoluble ion exchange resins, or insoluble uncharged materials. Polymers are long chains of molecules that produce highly charged ions and help bind microflock together into larger floor particles. They are very popular with operators because they are very effective and can be positive, negative, or neutral charged, providing a great deal of flexibility in different circumstances.